Hello and welcome to our weekly program, Pixel by NETSTAIRS, where we try to provide information, communication, and education about the technologies that we are working with as NETSTAIRS and helping our clients, our participants, those who are interested in the subject matter to gain additional interest and learn about it. Today, I've had the pleasure of talking to some of the consultants. One of our colleagues who manages BlockGeek, Sahi, has given us the permission to share some of his content with you. And as a result of it, we felt it's important sometimes where you obtain permission. So we do everything on permission-based relationship. We will be showing you two videos today as a part of our presentation. One part of it is going to be about H.264 that you're seeing in here that actually I am presenting to you. It's H.264 or VP8 and also talking about some of the VP9 and so forth. And the other side of the story is naturally talking about some of the new things that they have been working on since 2012 and according to their own claims, working with partners in this relationship, it doesn't exist. So we are striving to really show you some of the latest technology that is going on in WebRTC market, and at the same time educate you with some of the changes that is happening, and sometimes even taking prior content that we have obtained permission and revisit those content just to educate the market, such as maybe we set up a session just to talk about what is WebRTC itself, what does it do, because there are many subjects available for it. And we handpick those content because some of them are generic and some of them are biased toward a product or a company or a service. So our education is really trying to be unbiased and help understanding what this market is all about and why it's important for everyone to understand that WebRTC is here to stay. It's going to become the standards in our communications around the globe, building various exchanges, and we'd like you to be part of that. So without that, I'll put myself on the sidebar in here and start sharing the content with you and giving you some general idea.
So today about VP, or more specifically, how we're going to use H.264 or VP8 in your application. Now, to begin with, let's think a bit about live video processing, what exactly it means, or what are we going to use as the main technology for that. And if you had that question, then you probably looked at WebRTC. And WebRTC is probably going to be, or should be, your first and only choice for your technology stack. WebRTC is a standard specification that is part of HTML5. It is implemented by web browsers today, and it enables you to run voice and video calls directly from the browser using JavaScript code without installing anything else. It's quite a powerful protocol. Now, if you look at WebRTC and video codecs, and you put that in a frame of a technology generations, then the current generation of video codecs are H.264 and VP8. We're at the peak of that generation, and we're going to move on to the next one quite soon. Some say we've already started. The next generation is going to be HEVC, also known as H.265, and VP9. After that, in the horizon, there's AV1, the next best video codec out there that doesn't exist yet. For WebRTC, the mandatory to implement codecs are H.264 and VP8. It doesn't mean that you must support both of them in your application. It means that browser vendors need to support both of them to be WebRTC compliant. Now, the situation today is slightly different. If you look at the modern browsers that we have, they all support H.264 for WebRTC today. That includes Firefox, Chrome, Edge, and Safari. VP8, on the other hand, is supported only by Chrome, Firefox, and Edge. It is not supported by Safari today. And if you look at the next generation codecs, then Chrome and Firefox support VP9, which is optional, but they are still supporting it. Let's look at these codecs and what makes them different from one another. VP8 is the most common video codec in WebRTC today. Most of the applications out there will use VP8. And the reason for that, it was there first, and it is royalty free. You don't need to pay for patents when you use VP8 and process VP8 bit streams. On top of that, it has a simulcast implementation. If you recall from the previous session, simulcast means that we can now send multiple video streams towards the server, each one in a different bitrate, so the server can decide what to send to which participant in a group. Simulcast is very useful in group video calls. H.264, on the other hand, is the most widely available codec in WebRTC. It runs on all browsers today. It doesn't support simulcast, or the implementations of it in browsers don't support simulcast. It's also the most widely used codec outside of WebRTC. And it has the same capabilities when it comes to the quality of the video that you get for a certain bitrate. VP9 as a next generation codec requires more CPU and processing power to run, but it offers a better quality. It offers the best quality today when you look at WebRTC calls that you can run. It is also royalty free, just like VP8, and it supports SVC, scalable video coding, which makes it the best alternative if you want high bit rates in large groups. So how do we pick a video codec? With all of these alternatives out there, what should be the strategy that we should use? One option is to select the best codec for your scenario. I'm going to use, let's say, VP8 and decide that I'm not going to support Safari. Or I'm going to use H.264 and support everyone. I'm going to pick one codec and use that everywhere. The other alternative is to support multiple codecs and just pick the best one for the context that we have. So we're going to select dynamically per call or per session which codec to use. So what alternative are we going to pick? Banking on a single codec or using multiple ones? I don't really have a good answer for you. This is something that you'll need to figure out based on the requirements that you have in your service. Thank you for being with me for this session. See you in the next one.
So thank you for watching this.
Hi, I'm Tzachi.
So one of the main goals for me was to let you understand that we are working in this complex WebRTC with many encoding services. And we work with many CDN partners. And along with this, it brings a lot of diversity. With that diversity also, it's important to understand the client's need. That's one of the reasons it's important for us when we interview or spend time with the client, understand what are their intentions, what are their goals, their visions, their mission, their short-term, their long-term strategies for the use of WebRTC services. And based on that, we create or define or use different topologies. Probably in the next week or so, I will ask again from Sahir permission to talk about presenting his video on SFU, on MCU, and mesh technology. So this content, the reason I don't talk about it and I use this video is it is a document that they have granted us the permission to use. Two, also is coming unbiasedly that you can hear from third party. Now, next thing we're going to do is show you a video that is coming from initiative, we call it QUIC, QUIC. This is a WebRTC data channel. This is coming by Google, and I'll be sharing that video with you in a second. So take a listen.
I'm going to be talking mostly about QUIC, some about how QUIC can be used with WebRTC data channels, which does not yet exist. So I should preface this entire talk with all of the relevance to WebRTC is a future concept.
So notice one of the challenges in here that when you are talking, it doesn't exist. Just like Sahi says about certain topic, it doesn't exist. Because we are dealing with cutting edge technologies. We are dealing with frontier issues. So therefore, we want you to be aware that as we are taking you with the leapfrog toward the next level of real-time communications, deployment, and use within your own operating environment, both in governments, business, media, content, broadcasting, and so forth, you have a general idea that how we embrace these technologies with different subjects and we bring that diversity from different use of those WebRTC services from different suppliers and give you guys the opportunity to pick the one that is most suitable for your need.
Just like, but it's exciting, but it doesn't exist yet. So I should say that now. What is QUIC? QUIC does exist. It's a reliable multiplex transport over UDP. It's always encrypted. It's designed to reduce latency, particularly on the web, and particularly for connection establishment. It runs in user space, so we can upgrade it pretty rapidly. We don't have to depend on the kernel upgrades and the multi-year cycle that might require. And it's open source in Chromium. So everything I'm talking about here, you can look at it. It's in chromium.org. It's all there. We're running pretty much the same code, minus like a 1 week lag at Google that's in the Chromium repository. Okay, so where does it fit today? Right now, it's used kind of as an HTTP2 substitute inside Chrome. There's a bit of a shim to kind of do a little bit of translation, and the rest of it is QUIC. So QUIC handles the multiplexing of HTTP2, handles prioritization, handles flow control, handles reliability, handles a lot of things that TCP does on top of UDP. And that's where its relevance to WebRTC is particularly strong, is where it sits in the stack is very similar to where SCTP and TTLS sit today for WebRTC. So QUIC has congestion control and reliability. It builds on decades of experience with TCP, so we really tried to implement, all the best standards for TCP. It's a very modern style implementation, but it's an entirely new implementation. And there are some benefits to the new implementation because we're not stuck with the exact implementation choices that they made in the kernel, 5 or 10 years ago. As I said, it incorporates best practices, including a variety of things which are sufficiently new that they've been talked about and written about, but haven't actually become RFCs yet. But I also add some signaling improvements that can't be done in TCP. It took, I think, over 20 years for TCP to roll out SAC, which is selective acknowledgement. It turns out this is absolutely critical to making real-world networks work, but it took 20 years for it to roll it out. We can make changes in months. So an example is our loss detection tends to be much better because we don't have retransmission ambiguity. When we retransmit something, we know which one was at. But we also have a lot of flexibility going forward. So we can improve our signaling, we can change our signaling, all things that are essentially impossible with existing TCP, at least in the timeframes that are relevant to us. So a huge feature of QUIC is zero RTT connection establishment. That means that you can send the connection establishment request and the first, user data, first request, for example, in the case of HTTP, all in one go. So you send it like one packet after the other. This is kind of similar to TCP's TFO, the nice TCP fast open as it's referred to. The nice part is, number one, this actually works in the real world. No one really has managed to deploy TFO very widely in the real world because, again, TCP is really hard to change and hard to get new features deployed. But it also does the security handshake as well as the kind of connection level establishment all in once. And this works at Google about 75% of the time. So we're taking commonly 3 RTTs of connection establishment down to 0. So it's a huge win, especially for mobile connections, and especially where the RTT is large. So QUIC is always encrypted. The security is comparable to TLS. It actually uses the 2 ciphers that are available in TLS that are proven to be actually modern and secure and not hacked. So in some ways it's better than TLS because TLS still supports some older ciphers which are a little bit questionable. It has a more efficient handshake. It turns out the server CPU costs are a little bit lower on the handshake side. So resuming these connections is very cheap on the server side as well as on the client side. Has IP spoofing protection. So even though it has zero RTT connection establishment, it has a way of making sure that the person sending the packet is really that IP. That prevents DDoS and a variety of other issues. And it's already inspired TLS 130. So I'm sure that'll take a few years to get standardized. But TLS 1.3 includes a zero RTT handshake. And it's worth noting that, we've kind of managed to feed some technology from QUIC back into TCP already. So what can we do with QUIC and WebRTC? Well, QUIC shares a lot with SCTP and DTLS, which is exactly the standard underpinning today for data or peer connection. So it's a multiplex protocol. It supports a huge number of streams. I think it's by standard 4 billion, but I could be wrong, could be larger. It has flow control on both a stream level and a connection level. And so that's kind of a requirement for a modern protocol. And it's always encrypted, as I mentioned before. And it has out-of-order delivery. So unlike TCP, you can get out-of-order delivery semantics, and you kind of choose like what's in order and what's out of order.
One of the areas that I also want to add in here as a comment is we work with security-minded organizations. Security and privacy matters to a lot of our clienteles. And obviously, if they want to use public domain and so forth, those services are available. And there are many other fine and great services, third parties, that they provide, whether it's video conferencing or webinar or webcasting or view mode, live streaming, and so forth. With us, we've always been advocate of clients' privacy because we work mostly for the businesses and clients that they are bringing B2B to B2C or B2B to C. And then subsequently, we try to apply the best methodologies that is going to be introduced in the future that it doesn't exist, such as QUIC encryptions, that it allows us to create the most secure methodologies for privacy and security. To carry on.
So first, connection establishment would be the big benefit to data channel. Currently, it's 4 RTTs in the typical use case. Obviously, going to 0 is a huge difference, especially for applications such as actually making like voice calls on a mobile. This changes kind of the whole user experience. It also has reduced framing overhead. SCTP and DTLS, because they're layered one on top of each other, actually has a fair amount of framing overhead when you deal with smaller, payload sizes. So if you do attempt to do something like audio, which usually you wouldn't do over data channels, but if you did do audio over it, you would have a fairly large amount of overhead, kind of on a per packet basis. It also has improved congestion feedback. I actually worked very closely with one of the people who standardized SCTP, and he was complaining that a lot of things in SCTP were great, but there were certain things where QUIC really had a much better choice of implementation. And part of that is because he's now on our team, and he can say, no, we did it that way. That was the wrong way. You should do it this way. Mm-hmm. So how would you map data channels into QUIC? So QUIC right now is really oriented around kind of an HTTP2 semantic with reliable delivery. But it has all the features we need to do a wide variety of applications. So by default, it's ordered. QUIC streams implement ordering. But WebRTC also needs unordered delivery. But because we have lightweight streams, we can create just thousands and thousands of streams. I mean, you could even create a stream for every single audio and video frame. And I think it turned out you only ran out of them after like a day and a half. So, they're very, very cheap to create. And these allow you to easily do unordered delivery. And so you can kind of choose what's ordered and what's not. And that's really a critical feature of data channel. It's also, you can make it reliable, as it is typically used today, or it can be used unreliably. So as soon as you cancel a stream, no more data will ever be sent on it. No more data will be retransmitted. And that allows you to implement policies like max number of retransmissions or max time for retransmission. Again, standard features of data channel. So how does this look in terms of kind of an architecture diagram? We have the data channel API on the top. Kind of as similar to HTTP2, there's kind of a bit of a shim to adapt data channel over to QUIC. And then there's on the left-hand side, there's SCTP and DTLS, which QUIC is replacing. So it's replacing both the security layer and the streaming layer all in one. And then from then on, it looks fairly similar. So how could QUIC be improved for WebRTC? Today, there's still a few things that could be a little bit better. So QUIC has cancelable streams, but they're not fully unreliable. I mean, there's a little bit of overhead. There might be some optimizations to be had for just saying this stream is completely unreliable, set it and forget it. FEC. So QUIC currently has forward error correction. It's a fairly simple XOR-based approach. That means you can only recover one packet at a time. For audio and video applications in particular, media applications, it would be very helpful to have something that was more of a network coding type forward error correction, if you're familiar with that. So media-friendly congestion control. QUIC and Reno are terrible choices for real-time streaming media. If you're trying, or even to be compatible with real-time streaming media, they will, if possible, bloat a buffer to all get it. And so even if you have a data channel on the side of a real-time stream, you need to be conscious of what congestion control you're using for both, because you could inadvertently cause yourself a lot of extra latency in your real-time media stream by using the wrong congestion control, in your data channel. And then connection migration and multicast. So obviously, we talked about connection resumption a little bit earlier and kind of resuscitating state. But it would be awesome if a mobile device could migrate between Wi-Fi and cellular easily without having to do anything special on the mobile carrier part. So what's next? There's a lot of future work, improvements to forward error correction on the QUIC side, connection mobility, as I just mentioned, multi-path, and quite a few congestion control improvements. So all the things that I said we're missing are sort of lining up with all the improvements that we're planning on doing in QUIC already. But in terms of WebRTC, we haven't even got to the point where we have kind of an initial implementation, so we're still at the testing phase. We're making good progress. We need to actually run a real experiment on real applications and make sure that all of the connection establishment benefits and the other benefits fully bear fruit. And then it would be awesome to experiment with MediaStream API and actually see if we can do a combined unified transport for both the audio and the video and do everything over one. That's a ways down the road.
These are some of the areas that we are currently working on from experimentation and research point of view. We are building several topologies and several protocols. One of them that we are very interested about is obviously looking at the protocol of HTTP2 and QUIC and the use of its integration into trafficking the data and the packetizing and building the channels as they're talking. These are all part of the process that, unfortunately or fortunately, because of its newness and because of its being a bleeding edge and a cutting edge technology throughout the whole globe in terms of digital economy, we are trying to be at the way that we can communicate and help the clients for their adaptive, that it allows them their product life cycle or their service life cycle can extend to a longer duration than resorting to some of the prior older technologies that already is in marketplace. So there are two challenges that we have in here: deployment of the latest technology and taking the journey with those as these guys are building these settings that is going to come and replace everything else, such as HTTP2. Or are we going to sit down and stick to the same methodologies? This is where the visions of the management and organizations that they are not technology savvies comes into formation, that they have to bet on their company. We are watching companies, massive organizations, today's market, that they are continually making bad decisions. Their profit, their sales, their volume is dropping instead of embracing the technology and becoming the value changer and trying to help their customers, their supply chain, to use real-time communication as a tool. They resist, and with that resistance, their competition is really taking advantage of them. And this is where we are trying to bring this content from unbiased sources that we have worked and partner as technology partners, NETSTAIRS, with this group to educate you and help you understand that We can help you make decisions based on your present or future requirements. And this is the journey that we'd like to take with you.
So right now, it's all open source. There's an HTTP 2 test server in Chrome. We're working to get support for Apache Traffic Server, the clients in Chromium. Google Android and Google Chrome support it. And it's been presented at the ITF, and this summer we're doing a barb-off. So there's definitely a plan to move this towards standardization. And the plan generally is that we're going to probably standardize the crypto aspect as TLS 1.3, and then standardize the transport itself separately, and then different applications such as WebRTC, HTTP will use it. So summary, a quick summary. QUIC is reliable and multiplexed. It runs over UDP. It's always encrypted. It's designed to have lower latency connection establishment. It can have forward error correction. It changes all the time. Well, less so now, but it's, we can definitely iterate rapidly if we need new features. And it's all designed to be open source.
And again, since we work with open source and we work with partners in this kind of relationship, we embrace this, and then we take these as ingredients and start building things that you see right now in digital media rooms, such as DMR, that you're experiencing right now. And this is probably a good example where you can take a gold content, create relevance, build new update. And these updates can become the way that you can educate the market. Example is QUIC is a few months away that it has been presented to Internet Task Force Engineer, ITFE, to W3C, the WWW guys that you may know, and IEEE organizations for endorsement. And along with that, Microsoft has introduced a series of object code that they call ORTC. We're going to try to also bring some of that together and show you that WebRTC comes in different flavors these days, from simple RTC to easy RTC to versions of Twilio, for example, or into Jitsi or Janus or Frozen Mountain or any of these other organizations that they are all becoming key contributor into the technology, including Google with their QUIC platform. We hope you enjoyed this show. Stay tuned. We'll carry on some of these technical matters for some of our technical-minded IT departments, while we also talk about some of the other subjects that more is on the marketing and various topics. Thank you for joining us. Have a great weekend and see you soon. Ciao.